Hopefully this isn't. Hopefully I'm listening to JRE. Hopefully it's not too loud. I don't get like some copyright strike or some shit like that. 20.5. I should probably turn it down just a touch, huh? Hopefully you can't hear that. 20.5. Oh, I moved this. Yeah, get a double copyright claim. All right, so actually I should probably share this too. I put a little relief hole on the quartz. I actually burned through. The other quartz in my first attempt here. Yay. Because I was cutting it this way. I basically put a slice in and got the slice in, but then when I tried to put it on the end, it broke. But such is life. So I'm gonna start it up. I'm just gonna do a basic pressure test first. Make sure we're tracking the data a little more real time. Ready to go. We're going to start low. 100 volt divisions. Do have hydrogen and oxygen being produced. We have electrolysis going on. So verification of power, block it out 1. I better check the stream and make sure it sounds okay, looks okay. Yes. Yes, she does. It's good to know. So the purpose of this test is to try to get, it's still a stress test, but I'm going to try to make sure that the tube doesn't evacuate hydrogen too quickly. I might have made too much of a relief, but it's better that I have too much than too little, because it's hard to cut the quartz tube, and I can always put like a diaphragm or some type of gasket, a graphite gasket in the way. So let's share this here. Picked up my son. I got a couple like 3 hours to get in, so I'll run some experiments and see how she goes. Hope everyone's doing well on this wonderful Wednesday. I just got level 20 on a Discord. Let's see. All right. Ready to roll. Back to this. So like I was saying, I am listening to JRE quietly. Hopefully it doesn't Hopefully it doesn't show up too much. I don't think it will. Yeah, it doesn't look like it's showing up, so that's good. I'm gonna take this off too. It's freaking hot. Shout out to Brent for the Solana shirt. Maxis are gonna be showing Bitcoin Maxi is gonna be showing hate. It's a hate-free zone. All right, so let's do this. So far it looks good. I'm dumping a lot of power into it now. See, and that's another issue. If we don't bring the water level down, there's gonna be more surface area. There's gonna be more current flowing. So I'm not sure if I'll be able to get ignition until I raise the temperature up to like 60 degrees C. But we'll find out here. So this might be short-lived because it's just going to be too much current. Yeah. Yep. But we'll see if we can get the heat up enough. We started at 20.5. Let's see if we can get the heat up enough where it might start going here. 24. Just on normal hydrolysis too. Just on normal electrolysis with it like this. Let's take a look at so the magnetic field is really high. This analog meter, just with just normal electrolysis, which is kind of interesting. So I'm wondering why it's so sensitive. I've never noticed that before. Let's take a look at this too. This is the digital meter. This is 300 watts right now, dumping a lot of power. And if you look at the chart, you have to multiply the watts by 2. I still need to fix the code on that as well. It's another to-do project. So let's sit for 65. Or it's even worse than that. 101. I'm getting 310 on this, so it's probably like 250 watts. We'll just guesstimate there. And we have it here too. I can do calculations. Oh, no, we don't. Okay, well, that was dumb of me. Alright, I forgot to hook up the scope. What's up, Deeds? Long time no see, bro. Yeah. There's Proteus 3 was me replicating the original, what originally happened back in the apartment. So I can do that pretty well. Producing a crap ton of hydrogen right now. So I've got to be careful. I can do that, or Brown's gas actually. I can do that pretty well. To make that reaction happen, it just takes certain circumstances. You have to get the temperature right, and I have it down to a science. But yeah, man, it's good. Good to see you. It's been a while. You're the Slayer Exciter long distance record holder. My opinion, anyways. Maybe somebody beat you out there. Yeah, man. Three was pretty crazy, and that was exactly what happened in the apartment. And so having a round bottom flask helps with the flow of things. Having a magnet on the bottom and then having the graphite, the nanoparticulate graphite, all makes the magic happen. And then having the oscillations right, where you're keeping the tip of the wire, it will form like a molten ball, a sphere, and you're keeping that tip of the wire just in that top like that top zone, that the boundary layer between the gas and the liquid. It seems to be the sweet spot, and it just oscillates. And if you can get the oscillations where they aren't super slow, like what happened in the last one, then you can have some really impressive effects. Challenge is measuring that all in heat. That's been a huge challenge for me, because I've tried to do it on the outside. I've tried to do it in near the reaction. Even in electrolysis, obviously there's a lot of noise. The electrolysis isn't the problem, but once the plasma kicks on, it just bogs my sensors down. I think I've repeated this a shit ton of times, but it just bogs the sensors down. And I've been coding this MicroPython. I have this MicroPython here. I can't get it in screen, and I have this flow sensor meter, but it's garbage. It's just like 10% margin of error. I mean, hopefully the reaction would give us something that's greater than 10%, but it's too large of a margin of error to really say without a shadow of a doubt. Something burnt out. Yeah, I still have it in there. The jeweler's mesh. It has a platinum on the outside. It's just a platinum anode. It's a little brown. It's not the best, but these are just like stress tests and engineering parameters I'm trying to work out to make sure that when I run the experiment, like with the flask and everything, and I'm not able to see the reaction anymore, everything's working properly without me, because I won't be able to use the quartz tube anymore either. I discovered that last time. Like, if I'm going to be doing this, the quartz tube's going to be out. So I'm going to have to use an alumina tube in order to create the thermoacoustic effects, and which is kind of sad too, because piezo has quartz has piezoelectric effects as well, which I was hoping that would contribute, and it doesn't have as much thermal mass, so it's easier to calculate in the system. Now I'm going to have to calculate the thermal mass, like I'm going to have to calculate the thermal mass of the alumina in order to like factor that in for the temperature change. It's going to have it's going to change the specific heat capacity of the cell, which just adds more complexity to the system to really get a good idea of it. But that's the way it goes if I want to run it for a long time. Hopefully that makes sense. But yeah, I have two things in the works. I'm thinking about selling. In the next 6 months, we'll see what happens with the markets. But I'm thinking about selling a little Bitcoin, unfortunately, to be able to afford these things. So looks like there's quite a bit of heat and probably quite a bit of. I probably should get a fan on this actually. Yeah, we're at 39. fan on this just to circulate the air a little better. So the reaction is, the concept is to use cavitation and to be able to increase the probability of loading the nickel on surface, like I'll turn the fan off because it's too loud. Loading the nickel on the surface of oh, you know what? Let me fix something here real quick because I think this needs to be up here because I noticed that people aren't going to know what the fuck I'm talking about. I'm not sure if it's working. I put the chat box into the video, so hopefully people can see it. Otherwise, I'm gonna have to read all the chats. Yeah, there we go. Then people can read it. Be able to read what you're saying. All right. So, like I was saying, is the idea is to get the hydrogen into a vibratory state with high temperatures in order to create fusion. That's the idea, right? To make either shed the Coulomb barrier for and increase probability for the nuclei to hit, which is really unlikely according to standard science. Our standard hot fusion is the probability of it is very, very high, but in essence, instead of trying to force the hydrogen together, and in particular, hopefully increase the chances of deuterium in just regular water hitting too. That's the idea. Instead of trying to force it together, you're trying to oscillate it in like a kind of like liquefaction, like with sand. If you take sand and you vibrate the sand is impermeable to objects on top of it. But once you start vibrating it, then objects can go through the sand. That would probably be the best analogy I can think of. And there's other theories behind it, but I'd rather not like just get into all the theories. I'd rather just focus on, testing things, asking nature, and just hypothesizing, and then trying to test the hypothesis. So in standard hot fusion, there's several different methods, but they all pretty much involve forceful action, kind of like a combustion engine, like you're trying to blow shit up, basically, like in a weird way. You're trying to collide shit with each other. So, I guess a combustion engine wouldn't be the best analogy. Be a better analogy. Well, yeah, I guess that's probably the best I can think of right now. Probably should come up with a better one. But it could be, and this is the theory that's in for astrophysics, it could be that the stars are actually not gaseous bodies, but rather like lattice structures of metallic hydrogen or other elements in a plasma state, and they share electrodynamic interactions with other stars at a distance. It's like like point discharges and things of that nature. So it's more in I guess it'd be the quantum realm of trying to do things. Kind of opposes Arthur Eddington's model of like the nuclear furnaces. I think that there's truth in that, but then also I kind of think that there's probably more at play, because I'm more interested in, I hypothesize more in the electrodynamic happenings of the universe. I think that since it's so, electromagnetism is so much stronger than gravity, I think gravity might be an emergent property from electromagnetism. I mean, we've talked about this a shit ton, but the more that I look into it, the more that I'm kind of, I feel like that's probably has more potential. And of course that makes me, a fringe scientist, and people a lot mainstream scientists don't really share that view, most of them. But I'm not in the mainstream science, so I don't really give a fuck, right? Like I'm just asking nature, and there's ways that you can do it. This is one of the ways. That's my 2 cents on it, anyways. So, and there's a lot of evidence that suggests, even with just electrolysis experiments, that that there is this phenomenon happening of excess heat and helium production. And according to nuclear chemistry and according to nuclear science, that can only happen when there's something that's more than just a chemical reaction. When it's more than valence bonds, it's that release exothermic reactions. It's actually has to do with the nuclei of the atoms. So, I as much as I want to believe those people, like, I got to test it for myself and try different things. A lot of the replications, though, are really expensive. The only one that I noticed that it's not super expensive but is technical and is dangerous is Takaaki Matsumoto. And I'm trying to stay away from the high voltage stuff in a vacuum for 2 reasons. One is that it's expensive, and 2 is that it can release things like X-rays and things of that nature. And from all the literature that I've studied, this way seems to be a lot safer. For whatever reason, maybe the water has like a absorption rate that that other, like, a gaseous body wouldn't have, or the metal it's bouncing off metal and creating problems. I mean, there's lots of different hypotheses there too to be tested, but one step at a time. Anywho, I don't think I'm gonna push this too hard and try to get a reaction. Yeah, because there's too much current density, and for 2 reasons. One is I probably didn't secure the ceramic on the outside very well, and the other reason is because we're not creating that pressure. So what's up, Josh? Yeah, I understand why people would say that they don't believe in particles, just waves. I think of it more of is that it's fields, right? And a field has both particles and waves. That's just how we try to represent it. So that argument is kind of is a challenging thing to overcome, because we have measured both particles and waves according to actual sensors and experimentation, like for example, J.J. Thomson, discovering the mass of an electron, and Rutherford finding hitting an object that he called what do you call it? The Proteus, right? Project Proteus, right? Or protium, but it later became the nucleus, right, of an atom. So yeah, I've heard that argument, the strange radiation argument from Bob, and I've seen some electromagnetic spectrum stuff. But then I've also read other people's work that do these electrolysis experiments, and they say they haven't seen any dangerous levels of radiation. So that's why I'm sticking to the electrolysis experiments, as opposed to doing things that are more in a gaseous medium, like standard vacuum evacuated reactors with high voltages and stuff. So yeah, that's my take on that. I've done some high voltage experiments. I don't like to do them too much with electrolysis, where it's just on the tip of the surface tension of the water, and it does some really interesting things. It creates like little strings and stuff like that, but I don't like doing that too much because, again, it's high voltage, and I try to stay away from that. And yeah. Oh yeah, for sure. All data can be it's super easy to fool ourselves. That's the greatest challenge that I personally feel like we all got to overcome, is like to question ourselves enough to the point where we're like, okay, I've exhausted all ideas of what this could be, and then that's how we test our hypothesis, is we just keep asking nature until we come up to a conclusion we're comfortable enough with. That's at least my take on it. So you know, and then we release it into the wild and let other people have at it, and then but if you're comfortable with your conclusion and you've tested it to exhaustion, you know, you'd be able to be a champion for your idea, right? That's the idea. That's the purpose of the scientific method, to be honest, is to test everything to the best of your ability. The problem comes when, which happens a lot in mainstream science right now. You know, I think a lot of people probably agree with this, unless they have some personal investment or bias towards it, but is that there's this this push for deductive science, where you're trying to prove something right, and you can try to prove something right as much as you want, but it only takes one phenomenon to prove it wrong for it to be incorrect, right? So I personally think it's better to try to exhaust every way you possibly can to prove it wrong, and then that's how you can come to a conclusion of it being more right, right? Being closer to the truth. And but then again, like, some people think truth is absolute, and I don't necessarily agree with that either. I think truth is a continuum. It's like you're always pursuing truth. You're always looking for it. So always questioning, and it's never fully settled, you know, because we all die, right? So it's kind of a challenging thing. Yeah, you just keep trying to prove it wrong until you can't prove it wrong, and then you release it to the wild, and hopefully it's peer reviewed, but not necessarily peer reviewed, just it's replicated, and then other people can say, okay, I tried this and this and this, I have this other idea to prove it wrong, and if they can prove it wrong, then you can discuss that and be like, okay, well, here we go, that's this, and then you have to be strong enough to say, okay, I made a mistake. And that's like the biggest challenge in modern day society, I think, especially with social media and shit. Nobody wants to admit mistakes, and that's unfortunate. There's some people who are open to admit mistakes, but those people don't consider themselves experts. So like I'm no expert. I'm just really curious and passionate about this, because I think it has really strong implications for humanity, and my children, and hopefully other people around the world's children, and the people who aren't able to, you know, get basic needs met, like clean drinking water and shit like that. So I don't have a whole lot of money to start a nonprofit to go and try to help people, you know, in another country. So this is my contribution. That's how I look at it. That's how I've been looking at it. Hopefully it's not like some moral posturing or anything. It's not my intention. I'm just really curious about it. Oh yeah. So I actually was running. I have video of it that I'll post. I should probably organize a video that has all the many different experiments I've done and kind of go over it. It's something that I've been wanting to do for a while. It's just I gotta spend the time and actually sit down and fucking do it. But I agree with you. I was running this experiment once before, and then I ran it again when I was talking with Bob, because he kind of asked me to. So I ran it again, and it was because it was creating like strings. It was really strange. It was creating these strings, these like nickel strings. And I changed the parameters of it, and it's a high voltage DC. It's running at like 25 kilovolts DC, but it's low current, but very high, or low amperage, but very high voltage. And it creates these little strings. And I was using it's potassium carbonate. Yeah, potassium carbonate. And it was making these little strings, and it also makes these little, like, it's very bright, but it makes these little like rings too. These little rings come off of it and float around, And then also there is emissions off the top occasionally where it will like bounce around. In fact, I might be able to show it right here. Let me open a new Google window. It basically bounces around, and it does, is what Ken Shoulders explained too, which makes me like, oh okay, so I should probably be careful with this. So I agree with you, definitely be careful, take precautions. I'm just not using really high voltage for this particular experiment. It's more of a balance between voltage and amplitude and amperage. It still can be kill ya current. I mean, it's high current, but I kind of need that variability to create those thermoacoustic oscillations in the tube. So I don't have that, then I won't be able to replicate what I did in the past, which was almost accidentally. I mean, what I did in the past was my only intention was just to separate the oxygen and the hydrogen from each other, and then I noticed like the tube was oscillating, and then I remembered one of my first experiments I ever did with nickel titanium, and I had this. I was like really into waveguides and stuff like that, and I noticed that if I had it on the surface, it would increase the current density. So I was like, okay, well, what if I put like this latex or this graphite coated latex on the top that just kind of floats, but I sink it down below, so I create like oscillations on the wire itself, electromagnetic oscillations on the wire itself. What would happen? And that was a really interesting experiment, but it was hard. The nickel titanium melted very easily, but you could actually see the motions. And I didn't filter out the wall voltage very well at that time, so it was likely you could see a lot of the 60 hertz wall voltage, but you could definitely see oscillations. And I have a video of that one. That's the hydrodynamic star in a jar, or whatever it's called, where the music's way too loud and the editing's terrible. But that one, you can actually see kind of the nodes and antinodes, or the standing, how you could develop a standing wave if you got the frequency correct on it. And so I thought that was really interesting. But then later I did this where I was just trying to separate the oxygen from the hydrogen and see if I could just hydrogen, make the electrolysis, the water hydrogen rich, and make more deuterium by recycling it back into the system and letting the oxygen just vent off. But in doing that, when I got a plasma, the tube started to oscillate just like that original experiment, and then it led me to like think, well wait a minute, we could use this to our advantage. Like, you could create a resonant cavity that would create cavitation events, and at a certain frequency, like self-resonant frequency, and it has the potential of creating efficient means of either A, turning hydrogen into heat and light very easily, which could just be what it is, right? It might not be like a fusion process. It could just be simple. Like, I'm okay with that. Like, if it just turns it into heat and light very easily, that, just different spectrum of electromagnetic, of the different field effect spectrum. I'm okay with that. Or it can create like a fusion event. And what ended up happening is, when I was running this experiment, which you can see in Project Proteus 3, it's because it's the same experiment, I completely replicated it, and it did the same thing. It just all of a sudden it reaches a certain point where it goes critical, and I boil water very quickly. So I can't run the experiment too long. I'll have to engineer a circulatory system to where the water, like a distiller process, where the water feeds right back in to the reactor. And yeah, it was really interesting. So hopefully that makes sense. Most people wouldn't talk about this, giving away all their secrets, but I don't look at it that way, because it's all open source, and if somebody wants to take it and run, then great. Hopefully someone from ARPA-E is watching, or whatever. One of the big, right, as of the 24th, there's 10 schools who are going to start investigating this shit again, which is exciting. But it's also, I'm worried that, you know, because of the energy freedom paradox that I wrote this paper on it or whatever, but I'm worried that if they do find something, if, you know, if the government holds the intellectual property for it, are they going to want to let it into the wild? Are they going to want to release it as public information? I don't know. You know, that kind of concerns me a little bit, because, you know, there's talk of that happening in the past, and I think that if there is vested interest, you know, that could be possible. You know, human beings try to protect our power, like we want to keep power and maintain power sometimes. So let's hope not, but we'll see. Tungsten, stainless volts. I'm guessing around 5 amps. Yeah, that's interesting setup. Yeah, I strayed away from tungsten. I had a friend over in England who did the tungsten experiments a little bit, and he said he had a hard time. It would develop a lot of resistance in the cell. But I strayed away from the tungsten too because it has radioactive material in it, and like that's, some people say that could be beneficial. So, you know, it's your experiment, so have at it. But just my own personal choice, I was like, I'm gonna stay away from that. And then also I try to stay away from dissimilar metals. Now in this, I'm using platinum. That's supposed to not be, it's supposed to not break down in an electrolysis process as being an anode, but it does over time. I mean, everything will over time, especially at how hard I push it sometimes. In the past, I've used similar metals, but unfortunately, when you push nickel really hard, it will start to dissociate into the water. So that was a problem too. And I get little nickel pieces, like a nickel hydride in the solution. Actually, I have a whole bunch of different nickel hydride samples. This is a nickel hydride with a quartz tube, all stuff that can, maybe one day I'll be able to afford some EDM on, or ESM, ESM, or some X-ray diffraction or something like that. Oh, non-thoriated type. Yeah, that's true. Good point. Yeah, so it's only if it's thoriated. You're right. Yes, and stainless steel is pretty resilient too, but it does have like chromium and stuff in it. So I try to stay away from the dissimilar metals because it will, you know, you can have a galvanic response as well. And so it's just, that was just something that I was doing. But dude, have at it. Like, you know, just be safe. Just be safe, and please share if you get anything. Like, please share. I'm glad that we came across each other. I'm glad you found my channel somehow. That's pretty cool. Oh yeah, that's what I was gonna do. So if we go, don't think you can see it right now, yeah, but I'll put it up here. So if I go into, yeah, because I just uploaded this. So I'll try to share it. Yeah. Yep, I'm gonna have to rebuild it again. That's the way it goes, because it needs a little bit of pressure. You got to find that fine balance. You could probably see it's a 6-inch tube. Like I could probably find calculations for the thermoacoustic resonance of the thing. Probably would not be a bad idea to do. I'm gonna shut it off so I stop producing Brown's gas. Because I also wanted to be able to build up hydrogen in the cell as well, and try to keep as much hydrogen in the system as possible, as well as the water distillate going back into the system. Okay, so here's the video. I'll switch over here.
50 watts.
Oh, if I can pause it. not letting me pause it. I'll just open it. Get rid of the desktop audio. And I gotta clean up the lab a bit too. It's getting pretty messy. So close this, close this, and open up a new source. Screen capture, I think. I know, browser source. Source. No, it's not it. One second. Let's call it this. I'm not sure if it's going to let me do it. There we go. All right. You guys see that? Hopefully you can see that. And we will go to filters real quick. And add crop pad. Yeah, cool. Yeah, I've heard that before. I've heard someone suggest that before, borax, and also sodium, potassium carbonate is pretty good, and even KOH isn't too bad for stainless steel, but I've never tested borax myself. So down. There we go. Okay. So hopefully that's decent. I don't know if we'll see if this works. For some reason. Oh, son of a. I wonder if I full screen it, if it'll work. Let's see. Yeah. No, went black, huh? Okay, so I'm not gonna be able to full screen it. Hopefully that works. There we go. Still not working, son of a. Okay, hold on one sec. Oh, there we go. In and out. Come on. All right, so hopefully you can see it now. But you see it, there was an ejection from the top of it that kind of went off on a right angle. It's kind of interesting. That's something that Bob talks about. I don't know what to make of it. Like, it might just be just a excited nickel nanoparticle that freaking bounces off the surface or something like that. You know what I mean? I don't want to jump to any conclusions, but Ken Shoulders and would suggest that it's an EV and said you can make these. But then again, like, it could just be an encapsulated particle of the metal that you're using. So I don't know. I don't know. Looks like DNA. What you talking about, the mesh? Let's see if I'll zoom in a little bit. Like, I'm super open-minded. I just don't want to fool myself, or, like, you know, I remain skeptical. Like, I think it's important to remain skeptical. So okay, I'll play it again here. It's at the 27-second mark.
50 watts.
I don't know if I could pause it. Yeah, I'll try to pause it on the mark. There's one right there too, but the main one is like at 27 seconds. We'll see here. Oh man, it's so fast. Maybe I can get on it. It's so fast. It's like one frame. Oh, there it is. I don't know if I can get it on Adobe Premiere, but I don't know if I go frame by frame, and it literally is on one frame. Oh, it's so fast. But what's crazy about it is it takes like a right angle. I'm not sure if it's hitting the side of the wall. Too far. It doesn't look like it is, though. It just looks like it just takes a sharp right just for no reason. But the glass can be deceiving, right? It can magnify things. And it's moving so fast. Yeah, I don't know if I can catch it. Hopefully you guys see it, though. Was it showing? Hopefully it was showing that whole time. Kind of in and out. Like right around here, right after I take a temperature measurement. Right there. Yep. So that was a interesting little effect that happened. But I try to remain skeptical, like I said. So that's the high voltage one I was talking about. But anyways, that's pretty much all I got. I was just gonna test this and see if it works. It's definitely not building up a lot of pressure, but now I'm having the opposite problem, not building up any pressure. So I cut it too deep. So, which is okay. So I just have to put a little gasket on it, and like, I'll probably use I have a graphite gasket. I'll probably use like a graphite gasket or something like that, or even just some PTFE. Probably be fine on it. And then I'll give it another test tomorrow, hopefully by this weekend. Yeah, it may just be bouncing off the glass. Exactly. That's what I'm thinking. Is it just bounced off the glass? It took a really sharp right turn. But it was moving really fast, that's for sure. But the other one, I don't know if you noticed it, but the other one, it just rotated around it. So it rotated around the wire right at the base. So that was kind of interesting. That one's like it maybe just is affected by the electromagnetic field of the wire. That'd be my hypothesis on that one. I'll show that real quick, actually, one more time. We'll go for it one more time. It's like right at 3 seconds here, right here. Man, you can't even, it's hard to even see that one. I can see it on Adobe because I can zoom in on it better. But right there down at the bottom. It's really small though, it's hard to see. So that one's stuck close to the surface of the water and kind of rotated around it a little bit, which is kind of interesting. So yeah, but that's all I got for today. So thanks for watching, and if you got any questions or whatever, feel free to hit me up. I don't know, Deeds, if you have Discord, but you can hit me up on Discord anytime you want, or you can just wait for another video or whatever. So it's good to see, or good to hear from you, man. I hope everything's going well across the pond. Hope you're doing well, man. But yeah, guys, thanks for